like to thank Dr. Arun and the organizing committee for the workshop for inviting me. It's a privilege to be here, and I'm really elated to be speaking among such eminent speakers, and some of them are my seniors and teachers. So it really, brings me pride and joy, and as well as a sense of, responsibility that I'm speaking among such eminent people. So I hope that I can add value to this session and the people who are attending it. So as Arun sir has already introduced me, I'll not waste any time doing that again. I would just directly jump into the topic for today, which is deep learning for Indic languages. So this would be more of a like an application-based, application-oriented kind of a session, where we'll talk about what is the Indic language scenario right now. What are the different models and data sets which have come up recently, which we can use and to build some technology or some solutions around deep learning for Indic languages. And then we'll look at like a couple of use cases which we can deep dive into right now, and get our hands dirty with a collab notebook. So I have some stuff prepared, and I would share some links during the session with all of you. So let's get starting. So I would not go over this slide because that has already been done. Just to give you an outlook about the session. So first, as I told, like we'll just touch upon the Indian markets language scenario, then what are the recent developments when it comes to IndicNLP, quick hands-on session, and a quick look on the future scope of in this space. So the Indian language scenario is very unique and very interesting in its sense, and recently, a very famous account on Twitter, which is called India in Pixel, released this interesting visualization of 120 languages of India. And this visualization can be a lot to wrap your heads around at first, but it basically has all the major divisions or classifications of Indian languages, and then also lists all the sub-languages within each category, and further goes in detail and lists the further like some dialects of different languages as well. Now, basically, this visualization is based on the Indian census, which was done in 2011, in which the population reported around 19,000 odd languages, and the committee basically narrowed it down to 1,369 odd mother tongues. And then basically this visualization shows 120 languages which have more than 10,000 speakers in India. So just by looking at this visualization, we can get a sense of the diversity and complexity the Indian language space has. And just imagine, developing models and developing AI solutions for all these languages. Sounds very interesting as well as daunting at the same time. So I would like to narrow it down further a bit to show you this particular plot where we have all the languages which have more than 1 million speakers in India. And this count also goes to around like 30 odd languages which have more than 1 million or 10 lakh speakers in India. But this plot does not give us the complete picture, because it is incomplete without knowing where does English stand in this plot. And it is like quite a bit surprising that English stands like right below Tripuri, which is at the 31st spot, and the percentage of speakers which identify English as their first language is a meager 0.02%. And but this plot still does not give us the complete picture of the scenario. So I would add another marker to this plot, and we can see that the percentage of people who identify with English as their second language is 6.86%. And that mark just stands right below Bengali, which is the second most spoken language when it comes to the number of speakers in India. And this gives us a complete picture of the sense that we can understand that people who identify with English as their first language is very less in number, and but people who identify English as their second language is a lot higher as compared to the number of speakers of all the other languages. And the reason to bring up this plot and take you through the story is that through this we can understand what has been this scenario of language with respect to technology up till now, and what will it be going forward. So up till now, what was the scenario was that the technology which was being generated, and I'm not speaking only about the technology which was related to AI, and I'm talking about technology in a broader sense, which includes all the automation, was being created by the Western countries, mainly for English-speaking population of the United States or maybe the Europe. And then it was basically in the sense of globalization, the technology was coming to India, and people who had access to or who were comfortable with English as the language were interacting more with these pieces of technology. But as we are moving forward, this has started to change, and especially there has been a shift when it comes to the later part of the last decade. We have seen a shift that now people have started questioning that notion and started to more and more started to like there has been an increased demand of technology which can be easily interacted with in their indigenous language. And this has basically created like a shift into forms. So one is that even the technology which is getting produced in the West has seen a shift towards making technology more accessible in regional languages, in indigenous languages, so that people are more comfortable interacting with it. And the other is that people within India have also started to begin to solve problems which are very Indian in nature, and they've begun to solve it in India itself. So we've seen like a surge of a lot of startups coming in this Indic space and creating technology which is very easy to interact in their mother tongue. So what will be the scenario going forward? So according to a recent survey, the rural smartphone availability in India has approximately doubled since 2018 when it comes to 2021. And obviously the pandemic has also been an enabling factor for that, because a lot of rural families have gone ahead and purchased smartphone for their children's education, which is gone remote in the pandemic times. And this surge in the smartphone availability in the rural areas has basically increased the amount of people who want to interact with technology. And since technology is also moving towards more and more AI-enabled technology, I can take the liberty to say that people are want to interact more and more with AI in their own language, and that basically creates a very good opportunity as well as a very good challenge in front of the IndicNLP or the AI community to solve these problems and bring solutions which can engage these people who are not very comfortable with English, but are very good in their native tongue and want to interact with technology in their native tongue. I would like to, in the same sense, I would like to discuss a very interesting problem which I came across while I was reading a paper on an article on Google research blog, which basically talks about what is the scenario or what happens when a person is trying to locate a particular location in their native language. And they mentioned a very interesting use case where someone is trying to search for KD hospital, but in Gujarati language, in their native tongue. Now unfortunately or fortunately, it happens that a lot of places in India are named in English, or maybe they're acronyms, and this also like has a colonial touch to it, since we like have a colonial past. So a lot of places in India are named in English or with English acronyms, and if a person, and if the Google search engine is not able to recognize that a person is typing KD in their native script, it would give them a result which is like, in this case, CIMS hospital, which is like which is far away from the intended search, and that would basically ruin the experience of a search engine like Google. And and I would encourage the attendees to go ahead and read this particular research blog, because it calls for a very interesting reading on transliteration as a problem and translation as a problem, which Google is pioneering and solving for Indian users. And this topic was also covered by Dr. Manish in his inaugural address yesterday, wherein he mentioned what all technology Google is building and what all models Google is building to solve this multilingual problem, which is very unique and very interesting for Indian users. So when it comes to so this is the scenario up till now, but when it comes to the upcoming Indian NLP market, I think the space is even more engaging and interesting, because there have been like a lot of new startups which have recently come up, which are trying to solve problems in for Indians in Indian languages. So, for example, I have some data regarding a couple of startups which have recently come up in this space. So, for example, Pratilipi is a platform which is a long form story platform. So people can post and share long stories in their mother tongue on Pratilipi, and they've published more than 4.5 million stories in across 10 Indian languages, and they're trying to connect people with story writers in their own mother tongue. Then there is a company called Gnani.ai, which has built a voice engine for Indian languages. And the special thing about this voice engine is that it is just 100 megabytes in memory footprint. Now, this Gnani.ai is trying to solve problem for banking companies and other retailers who want to connect to their consumers via phone, and want to connect in their mother tongue, and how to scale these things. So Gnani.ai is working in that space. And there's a company called Skit, which has again built a speech to text engine which supports 10 Indian languages, covering more than 100 dialects. Now, this is like an additional thing which comes up when it comes to speech data, because the dialects also come in, and then there are very like a huge number of dialects in India. I think more than 1,500 dialects have been reported to be present in India. And people from the northern part of the country would know that anybody who speaks Hindi in Uttar Pradesh would be very different from a person who speaks Hindi in Bihar or Madhya Pradesh or Haryana. So all those interesting complexities Skit is trying to solve for call centers, and trying to automate text to speech and voice recognition and a question answer kind of problem for the call center kind of a business model. It is very interesting that from 2014 to 2019, $708 million of total funding has been raised by startups in this vernacular space. And this basically is an indicator of how large the business pie is, and how large the market is, and what is the motivation of these startups which are trying to scale up and get that pie. And a study done by KPMG also shows that out of the total 735 million internet users in India by 2021, 73% of them would want to consume content in Indian languages. And that is a very huge number and a very encouraging number for people who want to work in this particular space. So this is the all over idea of the market, and which basically tells an encouraging story for anyone within the AI community to go ahead and take a plunge in this particular space. So just to add to this slide, the interesting NLP problems which can come out of these startup stories is that imagine Pratilipi is trying to solve, trying to develop a platform for Indic users trying to consume stories in their mother tongue. But just imagine if we can build a very robust translation engine for all the languages in India. Maybe we can seamlessly write stories in one language and read them in another language. Let's say I write a story in Hindi, the engine translates it seamlessly into Marathi, and somebody sitting in Maharashtra can very easily consume that same story. So this is a very interesting kind use case, which can come in the times to come. So this has been the market scenario overall, but what are the developments in IndicNLP when it comes to the deep learning or the technical side? So we'll just have a quick look at the different problems or tasks which are there in IndicNLP. So obviously the first one can be language identification. So if I give you a text string, can you classify that string into a particular language? So that is like the very first use case. Then obviously there is machine translation, and this translation can go both from Indic to English and as well as Indic to Indic. So you can have Hindi to English as well as Hindi to Marathi or Bengali, like that. Transliteration is another use case where we don't convert words from one language to another, but we just change the script of the string. So let's say my name is Ankur in English is written as Ankur in English, but it is written as it is a Hindi word, but it can be transliterated to English by keeping the phonetics same as Ankur. So that's how transliteration works. And then there is text to speech and speech to text within and across dialects, which is another interesting problem. Then there is multilingual search. Obviously, Google is one of the pioneers in that, and Google is leading the path in that. Then there is natural language understanding, which involves summarizing content, understanding the user's intent, and maybe question and answers, like that. Then in an interesting domain within this space is Indian Sign Language conversion. So people who have hearing deficiency or interact in sign languages, and interestingly, sign language is also dependent on the geography in which a person is located. So sign language conversion to text and vice versa is also a very interesting NLP problem. And then there is Indic OCR. Obviously, we would all have seen that ad. I think it's Geo ad, wherein a person on a platform can just point a camera to an image which has text written in some southern language, and it seamlessly translates it into like a different language. So these are the different use cases and problems in this space. And obviously this list is not an exhaustive one. I'm sure there are other interesting problems which I have not mentioned here, and would love to hear from you if anybody can have any other ideas which are not listed. Now, when it comes to the data sets, there has been a continuous development going on in the data set space. And there was this initial data set which came out in the year 2000, which had 92 million words, and which was a monolingual corpora which was basically an effort to develop single language corpus in different South Asian languages. And then there is this Lipsic corpus, which has 1 million sentences. And then there is this Common Crawl project, which is basically like an aggregation of all the content which is present on the internet and has around 50 million words in Indian language. But recently, this AI for Bharat organization, which is like a pioneer in open source Indic language work, has come up with a corpus which has 8.9 billion tokens from across 12 Indian languages. And they've released this data set for public use, and they've also released a lot of nice models which are pre-trained on this corpus, which we can use out of the box and try to develop some interesting solutions in this space. And going forward in my presentation, I would take you to through a hands-on exercise where we will try to develop one interesting solution using one of the pre-trained models from AI for Bharat. Then there is this another corpus called Samanantar Parallel Corpus, which is like a corpus which has 46 million sentence pair between English and Indian languages and 82 million sentence pairs between Indian languages. So this is a very like a very rich corpus to train machine translation models on. And there is then there is this Dakshin data set which has 300,000 word pairs and 120K sentence pairs across Indian languages, and this can be used to train transliteration models. And the Google research blog which I was mentioning earlier is basically using this very data set, which is Dakshina data set, to train their transliteration models. And these are some of the open source models which have been released recently, which involve like an Indic transliteration repository on GitHub, which is a rule-based model to convert transliterate one script to another between different Indic languages. And then there is this Indic Trans, which has been released by AI for Bharat, and which is a deep learning model which can do transliteration across Indic languages. And obviously, AI for Bharat has released few more models, which are Indic BERT and Indic Trans, which basically have rich word embeddings, which can be used to build solutions for Indic languages. We would also be using some of the APIs which have been deployed. And shout out to Harveen Chadda, who has uploaded a few models on the Hugging Face website. And I would be showing you how we can use the API which they've hosted to build some cool solutions. So without further any more discussion, let's get our hands dirty and see what we can build and what we can do with all this information at our disposal. So I will be taking you through a notebook in which we'll try to use a pre-trained model to build a solution for Twitter. So I am a person who uses Twitter a lot, and I have been coming across this problem that sometimes people whom I follow tweet in their mother tongue, and they're not necessarily Hindi speaking people all the times. And in that case, I'm not able to understand what that person has basically written because I don't know that language. So Google, although Google provides translations on the page with a button click, but at times I just want to read it in my own script, which is not the case because Google provides translation in English only. So let's look at the problem and see how we can solve that. So to explain you the problem, I just have a quick tweet which I made as a demo for this session. So let's say I have tweeted that मैं ट्विटर के लिए एक अनुवादक बना रहा हूँ, which is basically a sentence in Hindi language, but it is written in English script. And for those who do not speak Hindi on the session, this sentence basically means I am making a translator for Twitter, right? So now let's say I have made this tweet, but somebody who does not know Hindi would not be able to understand my tweet, right? And this happens a lot with me. So now how can we solve this problem? And as I told you, Google provides the translation, right? But let's say I have clicked here, but Google could not translate this particular tweet of mine, and it just gave me the original string itself. So what can we do to solve such a problem, and what are the nuances of such a problem is the key area which I want to discuss. So I have divided the problem into basically a 2x2 matrix where the columns have the script and the rows have the language. So let's say a person tweets in an Indic language, and in Indic script. Then we just need to translate, right? Because it is written in Hindi, Devanagari script, and in Hindi language. We just need to translate. But let's say a person has written something in Indic language, but in English script. like the tweet which I have made. It is in Hindi language, but in English or Roman script. So in that case, we first need to transliterate this particular thing into the native script and then translate it to a different language. Similarly, if someone has written something in English language, but in Indic script, then we would want to transliterate that into Roman and then translate it to some other language. But if, let's say, the script and language are same, again, we would just want to translate. So it's time to like see some code. So I can share the link of the Colab notebook with you, and you can like download it at your end or like copy it at your end, and try to do or make changes to the code as we move forward. So I'll just paste the link in the chat. So this is the link for Google Colab, and I just also share the link for the GitHub repository of the code. And also I've also deployed the code as an application on Heroku, so we can just have a quick demo as well, and you can also go on this particular link and try to translate different tweets as per your wish. So if I copy the URL of the tweet and paste it here, and I just give the source language which is Hindi, and let's say I want to translate my tweet into can we have a show of hands about, like, can we like have a someone write on the chat to which language they want to translate this tweet to? Just to know that, like, just so that we can know what are the languages people who are on the session speak. Arun sir, is everybody else allowed to? Okay, I got a response saying Malayalam, so let's just try that. I hope it works, because generally code fail happens when you demo it live, right? Okay, so I do not know this script, so I cannot read it, but
yes, it's correct. It's correct. Okay, it's correct. Yeah.
Cool. So okay, I got a validation. So the demo worked. So I'm really happy, because I was thinking, like, most of the times the demo fails when you do it in front of live audience. So interesting. This is a very simple application, and it just works on basically this 2x2 matrix and some amazing pre-trained models which are basically available for us to use like in the open source domain. Okay, so let's see how we can build such a solution which is for a very day-to-day problem, or a very Indian problem, so to say. So I hope all of you can access this Google Colab notebook. If somebody is not able to access, they can raise their hand on the chat, and basically I am also going to walk you through this notebook on the session, so you can just follow along. So I'm going to use a couple of packages here. So I'm going to tell you what are they about. So I'm going to use a package called IndicTranslation, which is which is a very interesting repository built by some developers who have basically open sourced it, and this is a very efficient library to transliterate any given string into a different language. So you can see it supports like different Indic languages, and has like some very interesting functionality. So here they've given an example to like this particular string. They've translated it from a normal English script to Telugu and Devanagari, and again some other script to Telugu. And this can also like convert text like this to a lay Indian kind of representation, because when it comes to Roman script, we generally do not use Roman script in our day-to-day conversation on social media and chat applications. Okay, so this is a library which we are going to use. So let me just quickly install that. Yeah. So after I've imported the libraries, I have basically like created like a script map here, which has the language name as key and the script value, script annotation is the value, and for most of the languages it is just like a lowercase representation of the language name. But in the generic sense, it can be more than that, because for English we have like three scripts which can be there. So similarly, if like a language supports different scripts, you can add the script name in the list, and it would work accordingly. Then there is a pre-processing function which I've basically written to handle Twitter use case specifically, and this basically has only three lines, because the API which we are going to use, which hosts the pre-trained model, is very smart in that sense, because it handles a lot of pre-processing on its end only. So so the first step is to remove any web links present in a tweet. So let's say if there are any HTTP links, we need to remove that, because that was giving me some erroneous translations. Then I'm also removing any punctuations from the tweet, and I'm also removing the new line characters. So these are the only three pre-processing steps which I've built in right now. But you can easily add any pre-processing steps based on any other use case you want to port this code to. So so this is the pre-processing function basically which we are going to use. Now there is a function called indicize, which basically converts a given text into like a different script. So let's see how this function basically works. So let's call this function, and if let's say if I pass my name Ankur to this function, and I want to convert this into Devanagari script, let's see if this works. Yeah. So this function basically converts or transliterates a particular string into like a native script, and this can and the reverse of this function would be to Romanize. So if I want to convert, if I want to transliterate any string into English, I can do that using this particular function. So let's say if I pass this string again, and the script I want you to use is itrans. Okay, I got an error. Okay, the script needs to be okay. So I need to, the input to this function is basically the script which the language is in. So again, I would want to pass. So if I just give the source script, it would transliterate the string into the Roman script. Are we good till now, or is there any doubt which anybody wants to ask, or is there any question? Okay, I see that there was a request for Punjabi as well on the chat. So let's just quickly do that. So let's say I just take this URL and I put it here, and I can give Punjabi and Hindi, and let's see if it works. So I hope it is reading correctly, because I am not a person who knows Punjabi. If it is correct, you can like just tell us on the chat. So if there are no questions, we can move forward. Are we good? Okay, so I'll take that as a yes and move forward, because we have just 20 minutes left. So then there is this main function which is called Twitter and WAD, and this function is basically doing the business logic. What we're doing is basically we're taking a dictionary called form into this function, which should contain three parameters: the Twitter URL, the source language of the tweet, and the target language to which we want to convert. So I'll walk you through, basically the steps in the code, and then we will run it for a couple of tweets and see what output we are getting. And I would encourage you to try this same thing on your end, either on the app or in the notebook, and try to see if you can get the same output, or try more lengthier tweets and difficult tweets, and see what errors or what kind of interesting things you can uncover in this particular API. So if the Twitter URL is blank, we would just return no Twitter URL. And if the source language and target languages are same, again, we would return like an error message saying that the source and target language are same, right? If we have a valid Twitter URL, we would basically extract the like the Twitter URL ID out of that. So which is the last part of the URL. So this one. So this is the unique ID which Twitter provides to every tweet you do on the platform. And then there is this Twitter developer API, which you can use to get the tweet data from any public tweet, right? And for every account, you need to basically activate this API by going to the Twitter developer page and applying for like an API access, and they will immediately provide you with a bearer token, which is basically like a string, a long string, which is your unique key to access this API. And you can just send a GET request to this API to get the tweet out of that. So let's just quickly see, this particular tweet, API in action. Okay? Let's say if I use this very tweet, this ID. Okay, I need to define my token. So I had actually skipped this cell basically. I've got the response. Let's check what it has. Okay, so it is showing a 200 response code, and let's check the data in JSON format within this response. So when we check the JSON which is returned by this API, it would basically have the ID of the tweet and the text which is present within the tweet, right? So I had written this, and it is basically returning me the tweet, and that's essentially what we need from this API. So that's how it works. Now, when we've got the response, we would just extract the original tweet from the JSON response and basically send it to our pre-processing function to process the tweet and get a processed form of the tweet. Then I have used a quick hack to quickly detect the script of the particular tweet by just passing it through the function called Unicode data, because all the so every language is basically there's a representation stored for every word or every letter of every language within the system, and that is the Unicode representation. And for every character, you can get this Unicode representation or Unicode name for that particular character. So I'll just show you how this works. So let's say if I put A in this, it will give me Latin small letter A. So this is basically the Unicode name of this character. And let's say if I input like a Devanagari script letter, I take this and give this as an input. Okay, it is saying that only one character should be there. So let me, okay, yeah. Okay, still it is not taking. Yeah, so if I give one character as an input to this function, it would return me Devanagari letter NA. So it will basically have the script of this particular character in the first word of the response, right? So it is telling me that this particular letter is from Devanagari script. So this is a quick method to detect like which script the tweet belongs to, and then we can just have stored that response in a variable called tweet script, right? Are we good till now? So I would just like to, have some interaction on the session, because I don't want it to be like a monologue, especially when we're doing a hands-on session. If there is any confusion or any doubt, you can like write it in the chat.
Ankur, there is one comment, like screen size is very small, saying like maybe you can.
Okay, let me check if I can do that. Is this better? Is this readable?
Yeah, I think now it's
great. Thanks for the input, Arun sir. I hope everybody can read now. I didn't know it was very small. So yeah. So, okay, but let's say if so when we have this script name within our tweet script variable, then we would basically write our logic based on this 2x2 matrix. So we would say, if the source language is English, which is this row in the 2x2 matrix, what we'll do is we'll simply call the translation API and get the translation from the model, right? And then we would also once we have the translation, we would also Romanize that particular output into the detected script, and then send you the output, right? And then there is this else condition, which will basically handle the other part, which is if the tweet is in Indic language, right? So which is the case for my tweet here. So if the tweet is in Indic language, then we would see whether the first condition would be whether the script of the tweet is in English or Indic script. So we check if the Latin script is present in the tweet, then we would first convert it to the Indic Indic script by calling the indicize function, right? And then we would translate it. If the tweet is not in Latin script, then we would not basically indicize it, and we would directly call the translation API, right? And then again we would pass on the response to our return the response and the translated portion, right? Okay, so I hope I'm not going too fast, and it is it is clear to everybody, because we have I think I just brushed over the method because we just have 10 minutes left. So if there's any doubt, please tell me. Yeah. So let's say I have a sample form here where I have put the URL and the source in the target language, and execute that, and just print it here. I need to execute the script map as well. So now the algorithm says that English script was found, and then it indicized it to Devanagari and converted it to Bengali, and then also it is giving us the transliteration for that particular translation. So that's how the function is basically working, right? I hope the 2x2 logic is clear, and if there's any question, please go ahead. I also have another tweet. Let me just check. I also made a tweet in, yeah. So let's say I have a tweet which I have created in English language. So let's just try that as well. So now I'll give, okay, let's not change this cell. I'll make another cell. I'll tell the source language to be English, and let's say I want to convert it into, which language should I do? Let's say Hindi. Yeah. So we got Twitter के लिए एक अनुवादक उपकरण बनाने की कोशिश कर रहा है. So it's not like 100% correct, but it still comes very close to what the actual translation would be. Now there are some interesting things which we can observe here. One is that although it was the translation model was able to convert Twitter word, which is like a English word, to Hindi, and that's not exactly translation; it is actually transliteration. But the transliteration library which we are using could not convert this to again English very effectively, and that's because we're right now using a rule-based transliteration library, not a deep learning based transliteration library. So a deep learning based transliteration library would be able to handle these complex cases much better than what we are seeing right now. So this is basically a demo of like a very day-to-day use case which anybody can come across, and which involves like this very Indian problem of having too many languages, and especially having a mix, like using a mixture of English script, English words, and Hindi or other words from other languages in a mixture form, which we usually do on social media and chat platforms, right? So that's that I hope it conveys the idea of the problem and the nuances and the interesting solutions which we can build using these models. So I would just like to show you this page, which is basically the Hugging Face portal, on which Harveen has uploaded all these interesting models, and basically they can be called as an API, which I'm doing in my notebook. So basically this is the API which I'm calling, which is for this model, English to Indic translation model, right? So you can also go ahead on this platform, try to experiment with these models hosted there, and try to build any cool solutions which you can think of. So I hope this demo conveys the intended idea. Now I would just like to like bring the discussion towards an end by highlighting what is the way forward, or like an overview of what is a way to go for the IndicNLP space. So like although we're doing very well in translation of day-to-day language and social media conversations, there is another space within the same, there's another subspace within the space, which is making or creating machine translations for ancient Indian text or epics. And one of the important part when it comes to translating such documents is that we want to make sure that the non-translatable words in every language and their feel is basically retained and intact. And I would just quickly show you what I mean by this. And this also like calls for a bit of a decolonial approach, where we would see a colonial touch to especially the English translations available for our ancient Indian text. And because we are doing because we have a chance to create a new machine generated translations, it would be very nice if we're just very cautious about this particular aspect. So there's this famous data set which is called the ITIHAS data set, and it has like 75,000 pairs from two of the most popular epics of India, which is Mahabharata and Ramayana. And you can see that train validation and test splits have been given for this particular data set. And 75,000 pairs in train, 6,000 for validation, and another 11,000 for test. Now, if we just quickly take a look at like a word soul, which is present in the English translation of this data set, we would come across instances of such kind. But the very interesting thing is that this word soul has been used as a translation for a very Indic word which is called Atma. Now, if we were to go into the decolonial side of translation of Indic languages, we would and it is a nuanced domain, we would come to know that soul is probably not the best translation for the word Atma in Indic languages, because the word Atma is a non-translatable within the Sanskrit language. And such kind of nuanced approach should also be taken into consideration when we are trying to build AI or deep learning solutions for Indic languages. Another interesting example of a similar kind is the word religion. So the word religion is used for to translate the word dharma, which basically occurs very commonly in Indic ancient Indian texts, and that is basically a mistranslation. And since we're making these machine translations and these new algorithms, which might later enable interesting search engines and technologies for our ancient Indian texts as well, we might just want to be very careful of these mistranslations. So that is just a slight brief about how we can take a decolonial approach towards IndicNLP and developing machine translation models. The second point is the social media has opened a very interesting space where words from different languages and scripts are used in a mixture form. Very famously, these days we get language option in all the keyboard, almost all the keyboard, which is called Hinglish, which is a mix of Hindi and English. And such variations exist for probably other Indian languages as well. And that calls for an very interesting kind of a development cycle when we will be developing translation or keyboard kind of an application using deep learning models for such cases. Another very challenging and interesting domain is the speech domain. As I mentioned earlier, that due to approximately 1,500 dialects being there for the Indic languages, speech models especially become very challenging, because we might want to learn dialect invariant features when we are training a deep learning model. And I saw a very recent paper, as recent as January 2022, which has come out, which basically has made available like a model which is a pre-trained speech representation model for 23 Indian languages. So these are some recent developments which are happening, and which makes this space very happening and very interesting for people to come and develop more solutions and more models for better translation and better user friendliness. So that's about it, which brings me to the end of this session, and I hope I was able to convey that this Indic language space is very interesting with respect to the deep learning technologies, and I hope I've built enough interest in some of you at least to pursue this area going forward. After that, thank you for this patient listening, and you can contact me on this is A Shukla on all the social media handles, and this is my email ID for any queries or anything, and any queries are welcome. Thank you. I think there's a question. Let me just check. Okay, someone has asked that are abusive words or hate speech categorized non-translatable words? Yeah, very interesting question. So it might be, because I think every language has a very distinct slang vocabulary as well. So let's say the slangs which so I would not exactly go into the abusive words, because but they are also categorized as slang. So I think every region within India would also have different kinds of slang which we would use in that region, right? So North India would have some different kinds of slang, South would have different slang, like West and East. So these slangs are also can also be categorized as non-translatable words, because the category non-translatable words is essentially those words which capture capture a unique ethos and feel of that area, which cannot be replicated in a different language. So that word is basically called a non-translatable. And if an abusive word falls into that, fits that category, then so be it. And there's another question, which is why do we Romanize the text? Okay, so we what happens is let's say if you want to read a particular thing in Punjabi, but you do not know the Punjabi script. So let me just do this translation here. Okay, I lost the tweet. Yeah. So let's say this tweet is there, and I want to read this in Punjabi. So I translate this tweet into Punjabi, but I do not know this script, right? So as Indians, like in movies, we hear a lot of Punjabi, and these days a lot of Punjabi songs are also very famous. So we might know some words, or like have a very basic understanding of the Punjabi language, but we might not know the script of that language, right? So if I convert this to Punjabi language, and I have the Romanized version, maybe I can read that particular text, but not in that script. So there are two things, right? The language and the script. So that's why the 2x2 matrix was there. So that's why we Romanize. I hope I'm able to answer the question.